Okay, I want to look next at this particular problem. This was the other one that I posed a minute ago. And if we were to set out to find one of the missing angles here, let's find angle C this time just for argument's sake. So we'd have C squared, A squared plus B squared minus 2AB cosine C. So I notice it's exactly the same situation. It's side, side, side. So when we do our C squared, that's going to be 4 squared. A squared is 1 squared. 5 squared. And then again in parentheses, 2 times 1 times 5 times the cosine of C. And just like last time, we'll evaluate the squares and do the multiplying. So we got 16 here. We have 26 here minus, in this case, we'd have 10 cosine C. And then at that point, we'd subtract. So following the same set of steps we did last time. Alright, and if we divide, we get cosine C equals 1. Okay. And if we do the inverse cosine of both sides, okay, 1 is an exact answer, so hopefully we already know what the answer is going to say if we try to do that. Inverse cosine of 1, we get 0. So, let's think about that for a minute. Does that make common sense? 0 wouldn't make sense for that angle C at all, would it? Okay. So something's not right. So did we make a calculation error? Doesn't look like we made a calculation error anywhere. Okay. So how come the law of cosines didn't work in this case? Okay. I want you to think about the picture that I have drawn up there. Okay. If you look at that triangle that I have drawn there, if I lived at house A, think of that being like a map. If I lived at house A and I wanted to get to house C, does that picture make sense? And if not, why not? You may tell me what's wrong with that picture. If I'm at house A and I want to go to house C, okay, does that picture make sense? If I were to go to house B first and then to house C?
No.
Yeah, what's wrong with it?
It's an impossible triangle.
Ultimately, if I were to go the short way and go 5, and if I go the long way through point B and it's also 5, could that ever be reasonable?
Unless point B lies on the line between A and C.
And in which case, if it did lie on that line, then would it even be a triangle?
No.
No. So that's the issue. And if you remember from geometry, one of our properties was what we call the triangle inequality. Okay. That told us that if we have 3 sides of a triangle, that any 2 sides have to be greater than the third side. Doesn't matter which side we call what, but ultimately if you take the 2 smaller sides of any triangle, okay, they have to add up to be more than the third side, otherwise it wouldn't be a triangle, would it? Okay. So that's one thing you want to be careful with. In your directions on your homework today, it says to solve if possible. So could it be possible that it's not possible? Certainly. Okay. So you want to look at that first, and especially when you have that side, side, side case, that the 2 smaller sides, okay, add up to be more than the third side. Okay. Questions on that issue? Okay. There's one other case that I want to look at together here, and we're going to revisit our side-side angle case. So if you look at, I'm still on page 494 with you, they give us on number 13, they give us angle A is equal to 42 degrees. And side A is 7 and side B is 10. Okay. So if we were to draw that angle situation, 42 degrees, recognize that it's not the angle in between A and B, so that means it's a side-side angle situation. Okay. So that means that we could have a 7 over here, or we could have a 7 right here. Okay. So it's the ambiguous case. And with B being 10, here's our B, here's our A. So remember when we see that side-side angle case, that's the picture we want to draw every time. Okay, and label it as such. And then remember what we have here is we have 2 angle B's that are possible. We have 2 angle C's that are possible, C and C prime. And we call it C prime and B prime here. Okay, and of course we also have 2 side C's that are possible as well, the entire side from A to B, and the smaller side from A to B prime. Okay. So one thing to consider here is that we already know that with this information that we can use the law of sines to solve this. Okay. However, we could also use the law of cosines, okay, because we have two sides and an angle. Okay? And if we filled in the blanks on two sides and an angle, the only thing we wouldn't know is the third side. So just to illustrate the setup, the only one we can really use here is the one that has angle A in it, because that's the only angle we know. So we'd write a squared plus b squared, not plus, but equals, that is, b squared plus c squared minus 2bc times the cosine of A. So when we fill in the blanks here, we know A is 7, and we know B is 10. Okay. And what we don't know, yeah, we do know that one, sorry. B is 10, as we said. We don't know C. And we do know the cosine of A is 42. Okay. Alright, so we have 2 times 10 times C times the cosine of 42. Alright, so when we set out to solve that, we're going to get 49 equals 100 plus C squared minus, and in the parentheses we'd have 20 times cosine 42. I'm going to go ahead and just get a number for that and store it, so I have that in a nicer format. So 14.863 times C. Alright, now at that point what we want to recognize is that we have a C squared, we have a C term, and then we could put this 100 over on the other side, but if we have a C squared and a C and a constant, it's a quadratic equation, isn't it? Okay. So best case then would be to put 0 on that side and have C squared minus 14.863 C. And then over here we'd have plus 51. Now, as you can imagine, since we have a coefficient on C that's not very nice, is this going to be something that's going to be factorable generally ever? Probably not. So that means our only choice here would be to find the answers with either a graphing approach, okay, or quadratic formula. And I would suggest probably not using the quadratic formula, because again, this is a number that's not very nice. Okay, we had to round to get this. Okay. So at this point, our strategy would be to graph that and find the two intersection points. And remember, what's nice is that, and I guess it shouldn't be terribly surprising that we get two answers here, because remember, C is not only this length right here from A to B, okay, but C is also from A to B prime. We'd find two C's, wouldn't we? Okay, and shouldn't we find two C's, knowing what we know about this situation? You bet. Okay. All right, so I'm not going to go ahead and finish that. And one of the things that to consider here too is that if you had a choice when you have the side-side angle case, okay, would you ever choose this way? Okay. Would it be much easier just to use the law of sines? Okay. So again, the side-side angle case is doable with the law of cosines, okay, but definitely easier to apply with the law of sines. So again, given the choice, okay, I would only use the law of sines if it were me. Okay. But if you like complicated quadratic equations and you want to give that a try that way, you're more than welcome to try it. It's definitely reasonable to do. Okay. All right, any questions about that side-side angle issue? Any parts of the algebra steps or setup?